And 5, again, this is November 25, TZ1, HL. Some of these questions apply to SL, not Maclaurin series. But definitely check out my previous questions. It's in the playlist, and hopefully those help as well. So question 5, the first 4 terms of the Maclaurin series is this. Show that A is equal to 4 and find the value of B. Okay. And so what we have to do is use our formula. Our formula is what? F of 0 plus F prime 0. That's X F prime 0. Right? Just check the formula booklet. And then we have x squared over 2 factorial, f double prime of 0, and so on. And so we just use that. So our a term should be just our f prime of 0. So let's find f prime with the derivative. F prime of this is simply negative 4 bracket 1 minus x. We have a negative 1 as well. So we just multiply by negative 1. And this becomes negative 5, which is just 4, 1 minus x to the negative 5. Right, and all we have to do then is find our 0. So 1 minus 0, and that's just 1, so 4, which is equal to whatever they said. Now we can move on to B, find the value of B. Sorry, not B, part 2. And what we have is find the value of B. So now that's f double prime of x is equal to, we have to use this. So we have negative 20, that just becomes 20 because we have a negative. 1 minus x to the negative 6, right? And then all we have to do is find our f double 0 is equal to 20. 1 minus 0 is 1, which is 20. And then what we have to realize is there's a 2 factorial as well. So our coefficient b is equal to 20 divided by 2, which is 10. So b is equal to 10. Now, the car was purchased 4 years ago, depreciated in value by 10% each year. The value of the car today is 1,000. Now we have to use our result to estimate the value of the car 4 years ago. So, the car was purchased 4 years ago, 10% each year. So we essentially have to rewrite our equation with our determined values for x plus b was 10, and we had 20x squared, x cubed, sorry. And then we have is a discount factor, which is what we would tend to put here. We would put 0.1, right, as our x. So now our x here is also 0.1. And 0.1 squared plus 20, 0.1 cubed. And it's probably better to write this as a fraction. So 1 over 10 plus 10 times 1 over 10 squared, so 1 over 100, plus 20 times 1 over 1,000. And so we can simplify this. We have 4 over 10. Let's make all of these 1,000. So we have 1,000 over 1,000, 1,000 plus 400 plus 100 plus 20. And that's all over 1,000. And so that's 1,520 over 1000, which is our value for our depreciation factor, and we just need to multiply that 1.52 times our principal, which is 1000. So our value today is, this is our current value or future value, and our principal value is equal to 1520 because we had a depreciation by 10% each year. And so hopefully that made sense, and that's good, right? And this is our year number -4. And if you want to understand where this comes from, I can show you that too. So we have our formula: future value is equal to present value times, let me get exactly how it is in the data book. 1 plus r over 100k times k to the power of kn, right? And here there's no compounding period, we just have n, so there's no k. And what we need to find, and what we have is a discount rate, so this would be negative. And what we need to find is our present value. So what we have is present value is equal to, this becomes the inverse, so we have future value times discount rate to the power of negative n. And that's where we get our -4, and our minus x comes from this discount rate, 10% each year, right? So this is as a percentage. So r over 10 is equal to -10%, -10. And so that works out. Now we'll move on to question 6. We have a linear system of equations given by these. Find the values of a and alpha and beta for which the system has an infinite number of solutions. Right, so what we have to do is row reduction, right? We need to find system with infinite number of solutions. That means the end of our thing should be 0, 0, 0. Right, so if we, let's write this down, we have x, y, z, right? So x is 1, y is 0, and we have -1. We have 2, 2, 1, and we have 1, 1, 2, alpha, and this is 4, 14, and beta. Right, and this is what we're trying to reduce. So let's do this. We have, this is R1, R2, R3. So let's reduce R2 first. R2, we have R2 transforms into, let's do R2 minus 2R1. Right, and that gives us, okay, let me do this here. It's 1, 0, -1, 4. And then we have 0, right? And then 2 minus 0 is 2. And then we have 1. Now we have 1 minus 2, 1 minus minus 2, which is 3. And then we have 14 minus 8, which is 6. Next we have 1, 2, alpha, beta, right? Now we do this way. Right, and now we want to bring this to 0 and this to 0. So 1, we can use row 1, so row 3 becomes row 3 minus row 1, and that gives us 1, 0, 8, 1, 4, 0, 2, 3, 6. Now we have 0. 2 minus 0 is 2. We have alpha minus 1, alpha minus minus 1, which is alpha plus 1. And we have beta minus 4. So that's that. Now we want to make this 0. So let's do that. Let me just use the space we have. Put this 1, 0, negative 1, 4. And we can use row 2. So row 3 becomes row 3 minus row 2. 0, 2, 3, 6. Yeah, 0. 2 minus 2 is 0. Alpha plus 1 minus 3 is alpha minus 2. And then we have beta minus 4 minus 6. So beta minus 10. And that is good enough. Now what we want is, for infinite solutions, we need our whole last row to be all zeros. And so what we can say is a minus alpha minus 2 is equal to 0, alpha is equal to 2, beta minus 10 is equal to 0, beta is equal to 10. Right, because they're asking us to find the value. They're telling us that it has infinite solutions, so we don't need to show that. Okay, and that's it, right? These are our two answers. Now, in the case that they said no solutions, we would have something like 0, 0, maybe a minus 2, or we would have some number 2, and we would have 0, right? Or we would have 0 here, and we would have 2. So k. And then we have no solutions. And yeah. So now I'll move on to question 7 next. But we're going in pairs of 2 questions, so definitely check out the playlist for question 7 and 8 and everything before. And hopefully this helped. Please drop a like and subscribe.